Hi everybody. So we have finally made it to Python object oriented programming. This is a very important topic in Python. An object is a bundle of related attributes and methods. Attributes are similar to variables to describe what the object is. So look around you. Right now you are surrounded by different real world objects next to me. I have a phone, a cup, and a book. Each of these objects can have different attributes to represent it. For example, an attribute of the phone next to me could be version number 1, could set that to be 13, is underscores on. Could be another attribute is the phone powered on or not. That could be true or false, or even a price. I have a cup next to me. What liquid is within the cup? In this case, coffee. What is the temperature of the coffee? Is the cup empty? Is empty or even a book? What is the title of the book? That could be a string. How many pages does the book have? Pages could be another attribute. Now, objects also have the capability to do things. They have methods which are functions that belong to an object. People mix up functions and methods all the time. They are technically different. Even when teaching, I tend to make that mistake calling a method a function and a function a method. Usually people know what we are referring to, though a method is a function that belongs within an object. What are some actions these objects can perform with a phone? You can make a call or receive a call, turn the phone on or turn the phone off. Those could all be functions. With a cup, you could fill the cup, drink from the cup, or empty the cup. With a book, when you open the book, read the book, and close the book. An object is a bundle of related attributes and methods. They can represent real world items to create many objects. We will need to utilize a class A. Class is a type of blueprint used to design the structure and layout of an object. We need to design what our objects have their attributes and what they can do their methods. We will create a class of car. We will create some car objects. Class car. To construct a car object, we need a special type of method called a constructor. It works similarly to a function. We will define a function of double underscores in it. Dunder meaning initialize double underscore again and then allow this with a set of parentheses. This is our constructor method. We need this method in order to construct objects. It is a dunder method. Dunder meaning double underscore. That is a future topic. I don't want you to be overwhelmed with information right now. All you need to know is that we need this method in order to create objects. This method behaves similar to a function. We need to set up the parameters. Self is already provided to us. Self means this object we are creating. Right now, this car. So, what are some attributes that a car should have? A model that could be a string, like a BMW, a year that could be a number, a color. Let us add a boolean. For sale is the car for sale or not, that is true or false. To assign these attributes, we are going to access self. Set dot the name of the attribute. Set dot model equals the model we receive. These are parameters. When we receive the name of the model, we will assign it to this object. Let us do this with year. Self.year equals year. Self.color equals color. Self.sale equals for sale. This is an example of a few attributes that a car might have: a model, year, color, and if it is for sale or not represented by a boolean. Now to construct a car object, we need a unique name for this car. Let us just say car 1. Car 1 equals, take the name of the class, add a set of parentheses to invoke the constructor. We are going to do this almost exactly like a function. We have parameters set up. We need to send a matching number of arguments. Self is provided to us behind the scene automatically. We need a model, year, color, and if it is for sale or not. So pick a car of you are choosing. I will pick my favorite car. The model will be a Mustang. For the year, I will go with the recent year of 2024. A color, I will pick red. Is the car for sale? I like this car, so no. I will set that to be false. Make sure false is capitalized. Let us see what happens if I attempt to print our car object of car 1. What we are given is the memory address of this car object, where it is located. But I would like one of the attributes located at this memory address instead of printing the object itself. We are going to access one of the attributes found within this car. We will follow the name of the car with a dot. This dot, it is known as the attribute access operator. I would like the model of car 1. That would give me Mustang. Let us access the year. Take the name of the year, car 1 dot the year 2024, followed by the color, car 1 dot color, red car. Is it for sale? We will print that. That is false. Now let us create a second car. We are going to reuse this class to create a second car. We will create car 2 equals car. I will pass in some different arguments a Corvette. The year will be 2025. The color will be blue. Is this car for sale? Let us say that is true. Instead of accessing car 1's attributes, let us access car 2's attributes that would give us a Corvette. The year is 2025. The color is blue. For sale is set to true, or even a third car. Car 3 equals a new car. We will pass in a string of charger the year 2026. The color will be yellow. Is this car for sale? Let us say that is true as well. Then I print car 3's attributes. The model is charger. The year is 2026. The color is yellow. The sale is set to true. With classes, they can take up a lot of space. For better organization, you can place them within a new Python file. So let us cut our class and we will create a new Python file within our object folder, file new Python file. The name of this Python file is going to be all lowercase car. Then we will paste the class that we cut originally, class car, which has a capital C. So from the main Python file, we are going to import our car file. Our car module from the name of the module car, import the name of the class car. Then when I run this program, nothing should change. We should still have access to all of our car objects. You could either keep your classes within your main Python file or import them if they would like to organize things. Let us talk about methods. Methods are actions that our objects can perform within our class. We will define a method of drive self is going to be provided to us. When we invoke the drive function, let us print you drive the car. What other things can cars do? Let us stop. We will print you stop the car. Let us take car 1 access the drive method. You drive the car. Car 2 also has a drive method. You drive the car. Same thing with car 3. You drive the car. Let us access the stop method. Car 1 dot stop. Car 2 dot stop and car 3 dot stop. These methods are identical for each car objects. Instead of printing the word car, let us insert the model of the car. I will convert these print statements to F string instead of the word car. Let us add a placeholder. Let us add self.model. Self is referring to the object we are currently working with. Use the attribute access operator followed by the name of the attribute. Let us also do this with the stop method. Self.model. Let us take car 1. Use the drive method. You drive the Mustang car 1 dot stop. You drive the Mustang. You stop the Mustang. Let us do this with car 2. You drive the Corvette. You stop the Corvette. Car 3. You drive the Charger. You stop the Charger. Now within our F strings, let us insert the color. I will add a placeholder self.color. Do this with stop as well self.color. You drive the yellow Charger. You stop the yellow Charger. Car 1. You drive the red Mustang. You stop the red Mustang. Car 2. You drive the blue Corvette. You stop the blue Corvette. Let us add one last method. Let us create a method to describe our car. We will print the details of the car. Let us print. We will use an F string. Add 3 placeholders. Let us print self dot followed by self dot color. Then self dot model. We will take car 1. Use the describe method that we created. Describe car 1. Car 1 is a 2024 red Mustang. Describe car 2. Car 2 is a 2025 blue Corvette. Car 3 is a 2026 yellow Charger. Alright everybody, so those are objects in Python. An object is a bundle of related attributes. Attributes are variables that an object has, and methods are functions that belong to an object. They define what this object can do. And well, everybody, that is a summary of object oriented programming using Python. Hi everybody, today I got to talk about class variables in Python. Class variables are shared among all instances, meaning objects created from a class instance. Variables are defined inside of the constructor. Class variables are defined outside of the constructor with class variables. They allow you to share data among all objects created from the class with instance variables. Each object has their own version with a class variable. All those objects share one variable. Here is an example. We will create a class of student. We also need a constructor. When we create a student object this constructor is automatically going to be called, but we need to pass in some arguments. We are provided with self. Self refers to the object we are currently working with. We will set up a name parameter and an age parameter. We will assign self the object we are currently working with set the name attribute to equal the data for the name that we receive from this parameter, and self.age equals age. Let us construct two student objects. We will have student1 equals, then call the constructor for the student. So type the name of the class followed by a set of parentheses to invoke it. This will automatically call the constructor, but we have to pass in data for the name and the age for the name. Let us pass in SpongeBob, because basically everybody in the world knows who SpongeBob is. I don't know how old SpongeBob is. We will say he is 30. We will create another student object which we will refer to as student2. We will call the constructor of our student class, pass in data for the name, and each student 2 will be Patrick. Patrick will be 35. Okay, let us make sure this works. Let us print student 1's name followed by student 1's age, and we should get SpongeBob, and this age is 30. Let us print student 2's name and student 2's age Patrick. Patrick is 35. Now we will create a class variable. Class variables are defined outside the constructor and they are shared among all objects created from that class. Each object has their own name and age property. These are instance variables, but class variables are defined outside the constructor. Each object will share this one variable. So if we are working with students, let us say there is a class, variables of class year. What is the graduating year of this class 2024? Now let us print students 1's graduating year. Print student 1 dot class year. Okay, so SpongeBob has a class year of 2024. That is when he has graduating. Let us check student 2. Patrick is age 35. His graduating class year is 2024. Now with class variables you can access them through any one object such as student 1 or student 2. It is good practice to access a class variables by the name of the class rather than any object created from the class. Since we are accessing class year, we will access this class variables by the name of the class of student. Make sure the S is capital. This helps with clarity and readability. If I was looking at this print statement, I can tell that class year is a class variable because we are accessing it directly from the class and not any instance from this class. Without looking at this class, I cannot tell if class year is an instance variable or a class variable. But if I access it via the class name, it is more explicit. So it is good practice to access a class variables by the class name itself and not any one instance of this class. Let us create another class variable. We will create a class variable to keep track of how many students we have created. This class variable will be num students, meaning number of students equals 0. So within our constructor, we can write any code that we want. This code will always be executed when we instantiate an object. I would like to take our number of students and increment it by 1 each time we construct a new student object. So instead of using self refers to the object we are currently working with. If we are constructing student 1, just imagine we are replacing self with student 1 or student 2. If we were constructing student 2, if we are going to be modifying a class variable in place of self, we will use the name of the class student, access our class of student, get the class variable of number of students, then I will increment it by 1 plus equals 1. We are constructing two student objects. We will print x access our class of student, get the number of students and print it. we are constructing two students objects. If I print the number of students that we have, it should be 2. Then just to be sure that this is working, let us construct a third student object. Student 3 equals student. This student will have a name of Squidward. Squidward's age will be 55. Now we have 3 students, and for good measure, let us construct one more student 4 equals. We will create a new student with the name of Sandy. Sandy's age will be 27. The number of students is now 4. Just as an exercise using an F string, let us print the student classes, class year as well as the number of students. I will print use of F string my graduating class of. Let us add a placeholder access the place of student. Then access the class year my graduating class of 2024. Then we need the number of students. We will add a placeholder access the class of student. Access the number of students has blank students. Let us see if this works. My graduating class of 2024 has 4 students. Now if I were to change 2024 to 2025, my graduating class of 2025 has 4 students. Let us print the name of each student. These are instance variables student1 dot name. Then we need student 2, 3 and 4. My graduating class of 2025 has 4 students: SpongeBob, Patrick, Squidward, Sandy. Alright, everybody. So these are class variables. Class variables are shared among all instances of a class. They are defined outside of the constructor. The benefit is that they allow you to share data among all objects created from that class. And well, everybody, those are class variables in Python. What is going on, everybody? So today I got to talk about inheritance. In Python, inheritance allows a class to inherit the attributes and methods from another class, much like how a child in real life can inherit traits from a parent by having a class inherit attributes and methods from another class. This helps with code reusability and extensibility. In this example, we are going to create an animal class. The dog, cat, and mouse class will inherit attributes and methods from the animal class. We will create a class of animal. Then we will define the constructor when we construct an animal object. Let us pass in a name. It is not required, but it might be good for this example. We will assign the attribute of name equal to the name we receive. Let us also add an attribute of alive. Whenever we create an animal, we will set where is alive attribute to be true, and that is a capital T. All animals can eat. Define it. We will print using an F string. Add a placeholder self.name. The name of this animal is eating. All animals should be able to sleep. Define sleep print. I will use an F string. Insert self.name is sleeping, and this is all we need for the animal class. Let us define class dog. For a child class to inherit the attributes and methods from another class. After the class name let us going to inherit, we need to add an inheritance list with the set of parentheses. Then list the name of the class. We are inheriting from the parent. The dog class is going to inherit all of the attributes and methods of its parent animal. For the time being, as a placeholder, I will add pass just to demonstrate this class. Cat is also going to inherit from animal, and class mouse will also inherit from animal. Okay, I will collapse this for now. We will create a dog object. Dog equals dog. Then pass it a name for the dog. Because we have one parameter set up of name, this dog will be named Scooby, as in Scooby dot cat equals all the cat constructor. This cat will be named Garfield, and mouse equals mouse, or mouse will have a name of Mickey. Even though there is nothing within this dog, cat or mouse class, we should still have these attributes and these methods. If you inherit the animal class, you should have a name attribute and is alive attribute set to true. You can eat and you can sleep. Let us print a dog's name dog.name Scooby. Print dog is alive. Our dog is alive. That is true. Let us have a dog object. Use the eat method. Scooby is eating and sleep dog dot sleep. Scooby is sleeping. Let us replace dog with cat. The name of the cat is Garfield. Garfield is alive. Garfield is eating. Garfield is sleeping. And mouse replaced by instance of cat with mouse. Our mouse's name is Mickey. Mickey is alive. Mickey is eating. Mickey is sleeping. Even though these children classes are empty, they are still inheriting these attributes and methods from its parent of animal. This is convenient because we don't need to copy and paste these attributes and methods for every single class. For example, if I were to copy these attributes and methods and paste them, we have a lot more code to write, and as a consequence, if I need to make a change to one of these methods, I would have to do that to every single instance of this method. For example, let us replace is sleeping with is asleep well. Now I need to find every single sleep method and change it manually. It is not too bad if you only have a few classes, but imagine if you have hundreds of classes, that is going to take a lot of work. It is a lot easier to write the code once and then reuse it, and I only need to make that change in one place rather than make them change many times. So let us change in sleeping to is asleep and see if that works again. Mickey is asleep. Let us replace mouse with dog. Scooby is asleep. Not only that, but the children classes, they can have their own attributes and methods that are different from one another. So dogs have all these attributes and methods and they can speak. Let us have our dog speak off. Let us have our cat speak meow and our mouse speak. Alright, everybody. So, that is an introduction to inheritance. Inheritance allows a class to inherit attributes and methods from another class, much like in real life. A child can inherit traits from a parent. These are also known as sub and super classes, which is a topic for another day. Inheritance helps with code, reusability, and extensibility. If all of these children classes inherit these attributes and methods from another class, we only need to write that code once and not copy it for every single class that needs it. We can write and change the code in one place for better reusability and extensibility. And well, everybody, that is an introduction to inheritance in Python. Hi everybody. So today we got to talk about both multiple and multi-level inheritance. We will begin with multiple inheritance. That is when a child class inherits from more than one parent class. For example, a class of C can inherit the trait from both class A and B. In Python, you can have more than one parent, multi-level inheritance. We will talk about near the end of this topic. So, in this example, we are going to create two parent classes. Prey, I will write pass for now, and predator, we will create a class of rabbit, a class of hawk, then class fish. Rabbit, hawk, and fish are going to be the children classes. Prey and predator will be parents. If one of these classes, rabbit, hawk, or fish, inherit from prey, they get the ability to flee. We will define a method of flee. All we will do in this example is print the following text: this animal is fleeing. If you are a predator, you get the method to hunt. Define hunt. We will print this animal is hunting. Rabbits, they will inherit from the prey class. They are typically not predators except that one rabbit and Monty Python with the Holy Grail. That is the exception. Rabbit will inherit the prey class. Then it gets access to flee method. Hawks are predators. They will inherit the predators class. Now fish. They will hunt smaller fish and flee from bigger fish. You could consider fish both prey and predators. So they will inherit both classes. They will inherit everything from the prey class and the predator class. Now let us see if this does in fact work now. We will create a rabbit object. Rabbit equals rabbit. There are no parameters set up. We don't need to send any arguments to the constructor. Hawk equals hawk and fish equals fish. So let us take our rabbit object and they should have a flee method. Rabbit.flee method. This animal is fleeing, but they do not have a hunt method because they are not predators. Rabbit object has no attribute hunt. Hawks can hunt. They predators. They inherited that method. This animal is hunting, but they cannot flee. They are not prey. Hawk object has no attribute flee. Fish can do both. They inherit from the prey class and the predator class. Fish dot flee. This animal is fleeing. Fish dot hunt. This animal is hunting. Children class can inherit from more than one parent, which is what we did. For fish, they are both prey and predators, whereas in rabbits are just prey. Hawks are just predators. If you need to inherit from more than one parent, you just add that additional class to the inheritance list with multi-level inheritance. A parent can inherit from another parent. We will create a class of animal, and for now I will write pass prey and predator are going to inherit from the animal class. So we need to add animal to each inheritance list. Let us say if you are an animal, you get a method to eat. All animals will eat. Print this animal is eating and you can sleep. Define sleep. Print this animal is sleeping. So think of rabbit, hawk and fish as children classes. Prey and predators are those classes parents, and fish as children classes. Prey and predators are those classes parents, and animal is the grandparent. Prey and predator will inherit everything that the animal class has. A rabbit, hawk and fish will inherit everything the prey and predators classes have. So now our rabbit, hawk and fish classes should have the ability to eat and sleep, and we will test the rabbit dot eat. This animal is eating. Rabbit dot sleep. This animal is sleeping. Let us check out fish. Fish dot eat. This animal is eating. fish to sleep. This animal is sleeping. Okay, we are going to expand our example a little bit. Let me zoom out. Each of our object is going to have a name. Our rabbit will have a first name of Bugs. Hawk will be Tony as in Tony, Hawk. Our fish will be Nemo. Within our classes, we don't have any constructor set up in which class should be assigned the name attribute. Let us do so within our animal class. So we will define a constructor to assign these attributes. We will receive a name. We will assign self dot name equals name. Now with these other classes, if you are not assigning any attributes or if you don't need any other initialization logic, you don't need a constructor. We will implicitly use the constructor ROR we inherit from the parent. Let us convert each of these print statements to an F string. Replace animal with self.name. Now let us have a rabbit. Use the E method. Oh, we should get rid of this. There we go. Bugs is eating. Rabbit.sleep. Bugs is sleeping. Rabbit.flee. Bugs is fleeing. Let us check out our hawk. Hawks don't have a flee method because they are predators, not prey. Let us eat. Tony is eating. Let us sleep. Tony is sleeping. Let us hunt. Tony is hunting. Let us check our fish next. Our fish can eat. Nemo is eating. Our fish can sleep. Nemo is sleeping. They can flee. Nemo is fleeing and hunt. Nemo is hunting. Okay, everybody. That is both multiple and multi-level inheritance. With a multiple inheritance, a child can inherit from more than one parent class. You just add each additional class to the inheritance list with multi-level inheritance. A child can inherit from a parent which inherit from another parent class. C can inherit from B, where class B inherits from a think of C as the child, B is the parent, and A as the grandparent. C will have all attributes and methods even available within the grandparent class of A. And well, everybody, that is both multiple and multi-level inheritance in Python. Hi everyone, welcome back. So today I got to talk about abstract classes in Python. An abstract class is a class that cannot be instantiated on its own abstract. Classes are meant to be subclass. They are supposed to be parents to children classes. They can contain abstract methods which are declared but have no implementation. Abstract classes have a few benefits. We cannot create an object from a class that is abstract. Abstract classes, you could say, are incomplete. We don't want to create an object that is incomplete. Also, any children that inherit from an abstract class, if there is an abstract method, we have to implement them. So let me give you a demonstration. We are going to create a class A vehicle for now. I will write pass to work with abstract classes. We will need to import ABC. ABC meaning abstract base classes. We need import ABC. All capital meaning abstract base class as well as abstract method. So my vehicle class, it is going to be an abstract class. We will inherit from ABC the abstract base class. I don't want myself or any other developers to be able to create a vehicle object. I will make this vehicle an abstract class. Also, I can add some abstract methods. These methods will be inherited by its children to declare an abstract method. we need to use a decorator at abstract method. So what should all vehicles be able to do? Let us say go and stop. If you are a vehicle, you can go with abstract methods. We declare them, but we don't define them. We will define them within each of the children. Children classes that inherit from vehicle. Let us create another abstract method. Abstract method defines stop. If you are a vehicle, you can stop. Alright, we have finished our abstract class A vehicle. Just to demonstrate that we can instantiate an object from this class, let us attempt to do so and see what happens. I will attempt to create a vehicle object. Vehicle is equal to vehicle and then run this type. Error can instantiate abstract class vehicle with abstract methods. Go and stop. This is good. This is what we want. Our vehicle class is incomplete. We don't want to accidentally make a vehicle object if anywhere. It is kind of like the vehicle boat mobile from SpongeBob. Instead, we will create some children to inherit from this class. So now we will create a class of car which will inherit from vehicle. Car is the child, vehicle is the parent, but we are receiving a warning. Class car must implement all abstract methods. What we are saying is, if you inherit from the vehicle class, you need to include these abstract methods. So I am not going to currently. Later just see what happens. I will attempt to create a car object and run it. Type error cannot instantiate abstract class car with abstract methods. Go and stop. If a class is inheriting from a parent that is abstract and there is abstract methods, we have to finish defining those methods. So within our car class, really I will just copy this because I am lazy. Our method will go, we will print, you drive the car. We also need stop. I will print, you stop the car. Okay, let us see if this works. This has run with no problems. I will have my car go, then stop. We are calling the go method, then the stop method. You drive the car, you stop the car. Let us create a few more children for the vehicle class. Class motorcycle will inherit from the vehicle class. Again, we have to implement the abstract methods found within the parent. Go and stop. For go, I will print. You ride the motorcycle. Then with stop, you stop the motorcycle. Motorcycle is equal to motorcycle. We are calling the constructor. Then I will have our motorcycle. Go, then stop. You ride the motorcycle. You stop the motorcycle. Alright, last example. Let us say we create a boat class which will inherit from the abstract class A vehicle. I will include a go method where I will print you sail the boat, but I will forget to add a stop method because I am not paying attention. Let us attempt to create a boat. Well, what the heck is this type error can instantiate abstract class boat with abstract method stop. Then I will look over my code and see, oh, I forgot to include a stop method. With including abstract methods within a parent, it acts as a set of checks and balances. All vehicles should be able to go and stop. If I forget to define one of these methods, well, we will receive a type error if we didn't. I may not have noticed that we were missing a method. So now We need to include that stop method. I will print. You anchor the boat. This seems to have run with no problems. I will have my boat go and stop. You sail the boat. You anchor the boat. All right. All right, everybody. So those are abstract classes. It is a class that cannot be instantiated on its own. We cannot create any object from this class. We don't want to because it is well incomplete. They are meant to be subclass. They can contain abstract methods which are declared, but we don't finish defining them. We define them within the children classes. In this example, car, motorcycle, and boat, and well, everybody, those are abstract classes in Python. Hi everybody. So today I got to talk about the super function in Python. Super is a function. It is used within a child class to call methods from a parent class. The child class is the subclass. The parent class is the superclass. Hence why this function is named. The super function using the super function. It allows you to extend the functionality of the inherent methods. Here is an example. We will create a few shape objects. We will need to set up the classes. Though we will have a class circle. For the time being, I will just write pass. We will fill it in later. Class square and class triangle. For each of these classes, in order to instantiate objects, we will need a constructor. We will define our constructor, our init method. When creating circles, what sorts of attributes should be a circle have? Let us say a color. What is the color of the circle? Is it filled or not? Filled will be another attribute, and radius. Then let us assign this self dot color is equal to the color that we receive. Self dot fill is equal to fill. Self dot radius is equal to radius. Let us do this with the square and triangle. Really, I will just copy our constructor and paste it. Squares don't have a radius. With a square, the width and the height are the same. Let us replace radius with width. We will also keep the color and field attributes. Self.width is equal to width. Now with triangles again, let us copy our constructor. We will need a width and a height. Self.height is equal to height. So with programming, we try not to repeat ourselves if we don't have to do. All of these classes have in common. They all share the attributes of color and field. The ways in which they are different is that circle has a radius attribute, square has a width, triangle has a width and a height. If we have to make any changes to one of these attributes, we would have to do so manually. For example, let us replace field with is field. Now I need to look throughout my code for any instance of field and replace it with is field. It is a lot of work and I might make a mistake such as here, and here it is better to write your code once and try and reuse it. So that is where inheritance and the super function can come in handy. We are going to take the attributes of color and is field and place it within parent class. These children classes will inherit those attributes. So class, what do they all have in common? They are all shapes class shape. And for now, I will write pass. Circle is going to inherit from its parent of shape. That also applies with square and triangle. We will set up a constructor for shape defined in it. We will pass in the color and is field. Then we will assign these attributes. Self.color is equal to color. Self.isField is equal to isField. We don't need to manually assign these attributes within each of these constructors for the children. Instead, what we have to do is within the constructor for each of these children classes, we have to call the constructor for the parent, also known as the superclass of shape. So we will eliminate these two lines of code. Use the super function dot call the constructor of the parent, that is the dunder init method, but we need to pass in the color that we receive and is filled. This will be a boolean, and let us do this with the square class and triangle class. We still need radius for the circle, width for the square, width and height for the triangle. We are going to call the super function to take care of whatever our attributes all these types of shapes have in common, such as color and is field. Now let us see if this works. Let us construct a few objects. We will create a circle named circle called a constructor. For circle we have to pass in a color, a boolean of it is filled or not, and a radius. So for the color of the circle, let us say red. Is filled, let us say that is true, and a radius of 5. You could even use keyword arguments for better readability, although not necessary, but for clarity. Let us say color equals red, is field is equal to true, radius is equal to 5. Let us see if this works. I will print our circle. Color it is red. Print our colors is field. Attribute the circle is field. That is true. And the radius print circle dot radius. The radius of the circle is 5. We could even convert this to an F string. I will add a placeholder, then add centimeters 5 centimeter. Let us construct a square object. Square is equal to square. We will need a color is field. With a width, I will just copy what we have and make a few changes. Replace radius with width. The color will be blue. Is field will be false. The width will be 6. We don't need the height because squares have an even width and height. If we ever did the height, we can assume it is the same as the width. In this case, 6. Let us check out our square. Square dot color. Square dot is field. Square dot width. Our square is blue. It is not filled in. The width is 6 centimeter. Let us create a triangle object. Triangle is equal to triangle. Pass in our arguments. The color will be yellow. Is field will be true. The width will be 7 and the height will be 8. Let us print. Our triangle's color is filled. Its width and its height. Our triangle is yellow. It is filled in. The width is 7 centimeter. The height is 8 centimeter. So that is how you can use the super function to reuse the constructor of a parent class. We don't need to manually assign each of these attributes within each of the children classes. We can do that in just one place. When we refer to super, imagine that we are replacing this with the parent class name, such as shape. That might be a good way to think of it. Use the constructor of the parent class of shape and pass these arguments in. What you could do as well is extend the functionality of a method. So within our shape class, let us create a method of describe. we will describe the attributes of this shape. We will print, use an F string when we want to describe our shape. Let us say it is at a placeholder self.color. What is the color of this shape and is it fill or not, and add a placeholder. We will use a terry operator print field. If self.isField is true, else we will print not filled. Each of these types of shapes, circle, square, and triangle, will have access to a describe method. Let us attempt to use it. Take our circle, use the describe method that is inherited. It is red and filled. Square, it is blue and not filled. Triangle, it is yellow and filled. So then we also have method overwriting. What if we create a similar method of describe within circle, square and triangle? Let us do that. Define a describe method within our circle. Let us calculate the area. What is the area of the circle? I will use an F string. It is a circle with an area, and then we will calculate the area given the radius. To calculate the area of a circle, we can take pi. I will just say 3.14 just to keep it simple, times the radius squared. Self.radius times self.radius. If I describe to call the describe method, we use the parent version of describe or the child. So let us take our circle, use the describe method. The result is a circle with an area of 78.5. I should really add centimeter square. After that, centimeter square. This is called method overwriting. If a child shares a similar method with a parent, you will use the child's version and not the parent's. This is method overwriting. If you would like to extend the functionality of a method from a parent, you can use the super function. Not only do I want to use the describe method of the child, I would also like to use the describe method of the parent. So within this function, we will use the super function access the describe method of the parent. What we are doing is extending the functionality of the describe method. It is a circle with an area of 78.5 centimeters square. The circle is red and it is filled, or you can change up the order. Let us use the parent class's describe method and extend the functionality with our own print statement. It is red and filled. It is a circle with an area of 78.5 centimeters square. Let us finish this with the square and triangle classes. I will copy what we have for the describe method within the circle class, but we will make a different calculation. Describe the square. It is a square with an area of take self.width into self.width. The height and the width are going to be the same if it is a square. Then describe a triangle. It is a triangle with an area of width into height divided by 2. We have already described our circle. Let us describe our square. It is a square with an area of 36 centimeters square. It is blue and not filled. Let us describe our triangle. It is a triangle with an area of 28.0 centimeters square. It is yellow and filled. Alright everybody, that is the super function. It is used in a child class to call the methods from a parent class, also known as the super class. It allows you to extend the functionality of the inherited methods within a child class. You could use it within a constructor to assign any attributes that all of its siblings have the common such as color, shape, is field. When used within any other method, you can extend the functionality of that method. Not only are we printing this message from the parent, we are tacking on another print statement before that. And well, everybody, that is the super function in Python. Hi everybody. So today I got to talk about polymorphism. In Python, polymorphism is a programming concept. It is a Greek word that means to have many forms or faces. Poly means many, morph means form. In programming, an object can take one of many forms. There are two ways to achieve polymorphism. One is through inheritance. An object could be treated of the same type as a parent class. There is also duck typing, which we will talk about in the next topic. In this video, we are more focused on inheritance. What we will do in this video is create a class of shape. We will write pass as a placeholder. We will create a class of circle which will inherit from shape. Again, writing pass class. Class square inherits from shape class. Triangle which inherits from shape. If I was to create a circle object, circle is equal to circle. Our circle identifies as a circle, and since our circle class inherits from the shape class, our circle is also considered a shape. It has two forms. It is a circle and it is a shape. But our circle is not a square or a triangle. That could also apply to our square class. Our square is square. Our square is also considered a shape, but our square is not a circle or a triangle. Those are two possible forms for our square. It is a square and a shape. So let us say we would like to create a list of shapes. What do they all have in common? Well, they are all shapes. A descriptive name for this list would be shapes equals an empty list. I will instantiate a circle object, a square object, and a triangle object. Our circle is a circle and a shape. Our square is a square and a shape. Our triangle is a triangle and a shape. Each of these objects has two forms for two faces. Let us fill in some of these classes. Let us say that with our shape class, we will define an area method. Define area. I am going to turn this into an abstract method. I will just write pass. It works with abstract classes. We need to import that from ABC. Import capital ABC as well as abstract method preceding the area method. I will add a decorator of abstract method or square, circle, square and triangle classes. They are all considered shapes. They inherit from this class. We need to define an area. We need to define an area method for each since they are all considered a shape. Every shape has an area with our class of circle. Let us define a constructor. Define init. We will pass in one argument, a radius. What is the radius of the circle? Assign an attribute of radius equals the radius we receive. Let us do this with square. Define init. Our parameter, the length of a side. Self.side is equal to side. Then triangle. Define init. We have two parameters, base and height. Self.base is equal to base. Self.height is equal to height. Alright, now let us finish defining these area methods for each class. We will return 3.14 times self.radius to the power of 2. So given a radius, that is how to calculate the area of a circle. Then with our square define area, we will return self dot side to the power of 2. Then with our triangle define area, return self dot base times self dot height times 0.5. Now we have to pass in some arguments. For our circle we need a radius. I will pick 4 for square. The length of a side will be 5. Then our triangle, the base will be 6. The height will be 7. We are going to write a loop to iterate through our shapes for every shape in shapes. Then we are going to print for every shape called the area method, and that would give me these numbers. If you would like, you can format the output. I will just use an F string. I will add centimeter square, which much better. What if we were to create a class that is completely unrelated to shapes? I will create a class of pizza. I will define a constructor to construct a pizza object. We need a topping and a radius. What is the radius of the pizza? Self dot topping is equal to topping. Self dot radius is equal to radius. Within my list of shapes, I will add a pizza object, but I have to pass in a topping such as pepperoni. And what is the radius of the pizza? Let us say 15 centimeter. So our pizza class doesn't have an area method. Here is what happens when I run this. We get an attribute error. Pizza object has no attribute area. Our pizza object is considered a pizza, but it is not considered a shape. It does not inherit from the shape class at the top here. You know what a pizza is circular. It could be considered a circle. So how about this? Let us take a pizza class. It will inherit from the circle class, and within our circle class we are already assigning the radius to the radius attribute. So instead of doing that, here within the constructor for our pizza class, let us call the super constructor. Super, which refers to the parent, use its constructor. Then passing the radius we receive. Let us see if this works. Now that does. Here is the area of our pizza. Our pizza is considered a pizza. It inherits from the circle class. So let us also consider a circle, and our circle class inherits from the shape class. Our pizza has three forms. Our pizza is considered a pizza. It is also considered a circle, and it is also considered a shape. It would make sense for it to fit into this list of shapes because our pizza also identifies as a shape. So that is polymorphism. It is a Greek word meaning to have many forms or faces. Poly meaning many. Morph means form. In Python, there are two ways to achieve polymorphism. One, through inheritance. An object could be treated of the same type as a parent, and there is also duck typing, which we will discuss more in the next topic. Stay tuned for that. And well, everybody, that is polymorphism in Python. Hi everybody. So today I got to talk about duck typing. In Python, duck typing is another way to achieve polymorphism. Besides using inheritance, objects can be treated as if they are typed as long as they meet the minimum necessary attributes and methods required of them. It follows this adage: if it looks like a duck and quacks like a duck, it must be a duck as long as an object reassembles another. It could also be treated of that type. So in this example, Let us create a class of animal. We will have a class attribute of alive. If you are an animal, you will have an attribute of alive. You are a living creature. Let us create a class of dog. The dog class will inherit from the animal class. They will inherit the alive attribute. Let us also define a speak method. If you are a dog, you gain the ability to speak. You will print oof. Then we will create a cat class. Class cat inherits from animal. For the speak method, we will print meow. Let us create a list of animals. What do these two classes have in common? They both could be considered animals. Let us create a list of animals. We will construct a dog object and a cat object. If I was to write a for loop for every animal in my list of animals, have each animal use its speak method, which will result in the dog going oof, the cat going meow. They are both speaking. What if we add a class that has nothing to do with animals, like class car? Cars will have a horn method. That is how they speak. When you honk the horn, you will print honk. Within my list of animals, let us create a car object. It really doesn't belong in here, but let us see what happens. We have another attribute error. Car object has no attribute speak. Our car object doesn't have the minimum necessary attributes and methods when iterating through this list of animals. We are calling each animal speak method, which our car object doesn't have, but it does have a horn method. So what if we rename our horn method as speak? Maybe it is an AI car or something well. This would work. The dog goes oof. The cat goes meow. The car goes honk. So our car object is quacks like a duck. We could consider it a duck. It has the minimum necessary methods to be considered as animal. Animals inherit this alive attribute. Let us utilize that after the animal speaks. Let us print AI live attributes print. My animal's AI live attribute. My car object doesn't have that attribute. We get an attribute error. Car object has no attribute alive. But if I was to add that attribute alive equals false, we have true for the dog. It is living true. For the cat, it is living, but false for the car. It is not living. It is not a living creature. My car meets the minimum necessary requirements to be considered an animal. If I were to set this to be alive, well, then it would be a living car, kind of like the movie Cars. So with Python, duck typing is another way to achieve polymorphism. Besides using inheritance, as long as an object has the minimum necessary attributes and methods, you could treat it as a different type of object. If it looks like a duck and quacks like a duck, it must be a duck. And well, everybody, that is duck typing in Python. Hi everybody. So in today's video, I am going to explain aggregation in Python. Aggregation represents a relationship where one object contains references to one or more independent objects. One object acts as a container, the whole, which can contain other objects, the parts. So what we will do in this demonstration is create an object that is going to act as a container. We will create a class of library for now a write pass. Now a library can contain books. we will create a class of book. We will be creating book objects which we will add to our library object. The library object is going to act as the whole, the container. The books are the independent parts. A library can exist without its books, and the books can exist without the library. That is the main difference between aggregation and composition. These classes are independent of one another. They can exist without each other. With our class of book, we need a constructor. We will define our constructor. If we create a book, we need a title and an author. We will define a title attribute equals the title that we receive, and self.author is equal to the author. That is all we need for the book class. Now with the library class, we will also need a constructor. Define init. For our library, we need a name for the library. For example, the New York Public Library self.name equals the name that we receive. Let us construct our library object. First, library is equal to li library. We need to pass in a name for this library. Let us say New York Public Library. So this should run with no problems. Then we will create a few books. Let us say book 1 equals called the book constructor. We have to pass in a title and an author. To pick a few books, I will pick Harry Potter, Happy Harry, Harry Potter, and the Philosopher's Stone. But I don't want to type the whole title. Let us just say Harry Potter do the author of this book is J.K. Rowling. Okay, let us create another book. Book 2 equals book. For my next book, I will pick The Hobbit. The author is J.R.R., our token. Then book 3 equals book. We need a title and an author. I will pick The Color of Magic by Terry Pratchett. We have no problems when running this our library, and our books can exist without each other. Our books are independent. So now, where aggregation comes in our library, object will contain our book objects one way in which we can handle. This is that within the constructor for our library. Let us create an attribute of books. This will be an empty list. We will need a way to add these books to our list of books. We will define a method of add book, but we have to pass in a book object. When we call this method, we are going to access self.books. It is a list. List have a built-in append method. We will append our book to our list of books. Let us see if this at least runs. We are going to take our library, call the add book method that we defined, then pass in our book object of book 1. Then let us do this with book 2 and book 3, and this is run with no problems. Our books can exist independently of our library. Our library object is just containing them. It is housing these books. Now, if I would like to print all the books in my library, I could create a method to do that. Let us define a method of list books. There will be no parameters besides says I am going to return a list. Comprehension for every book in self.books. Remember that books is a list for every book. In books, let us return an F string where we display the book's title and the book's author. Display book dot title the word by book author. Okay, Let us see if this works. First, I am going to print the library's name. Print library name, New York Public Library. Then I am going to print access the library objects list books method, and here is my list of books. Although I am going to reformat this so it looks better. I will use a for loop for every book in access our library objects list books method. This will return a list. We can iterate through it for every book. In the list of books, print each book. Alright, here is our library name and each book in our list of books. Alright, everybody. So that is a aggregation. It represents a relationship where one object, the whole contains references to one or more independent objects. The books they can exist without one another. And well, everybody, that is aggregation in Python. Alright, everybody. So today I got to talk about composition in Python as we have discussed in the previous topic. Aggregation is a relationship where one object contains references to other independent objects. They have a relationship composition. On the other hand, is when the composed object directly owns its components which cannot exist independently. They have owns a relationship. Aggregation has things. Composition owns things. Kind of like you are renting or you are owning something. In this example, we will create three classes: a class of engine, a class of wheel, and the composed object is going to be class car. Within our car class, we will construct some engine and wheel objects. We will begin with our engine class. We will need a constructor. We will define in it. Let us say that with an engine we need a horsepower. What is the power of the engine? Self.horsepower attribute equals the horsepower that we receive. With our class of wheel, we need a constructor. Define in it. Let us add a size attribute. What is the size of the wheel? Self.size is equal to size. Okay, now with our car object, now within our car class, we need a constructor. We will need a make model, the horsepower of the engine and size. We will say wheel size. Remember that you can rename parameters to something different we will assign. These attributes self.make is equal to make. Self.model is equal to model. Here is where composition comes in. We will define an attribute of engine. They call the engine constructor. We have one argument to pass in horsepower. We will pass in the horsepower that we receive to the engine constructor. Then we have to set up our wheels. Self.wheels is equal to, now to construct a single wheel object we could call the wheel constructor. Then pass in the wheel size. However, car have four wheels. We don't want just one wheel. So what we could do is write a list comprehension for every wheel in range 4. To iterate 4 times, let us call the wheel constructor and pass in our wheel size. This list comprehension will create 4 wheel objects for us. The reason that this is considered composition, we are creating engine and wheel objects inside of this class car. Our class car owns an engine and owns 4 wheels. We are not creating these objects outside of the car class. Let us create a car object. Car is equal to car. We need a make model, horsepower for the engine and wheel size. So for my car, let us say Ford Mustang. For the horsepower, I will make up something 500. For the wheel size, 18-inch. Now just to make this more explicit, I am going to use keyword arguments, but you don't have to. So make equals Ford model is equal to Mustang, horsepower is equal to 500, wheel size is equal to 18. Let us create a method to display our car. I would like the details. Define display car no parameters. Let us return an F string. Let us begin with the make and model. Those will be easy. Display self.make and self.model. Let us take our car object, use the display car method. Then I got to print it. I forgot because we are returning a string. We are not printing it directly. We have a Ford Mustang. Okay, let us display the horsepower. There is one additional step. We are accessing self this car that we are creating. But now we need the engine. Let us access the engine attribute. And now with our engine has an attribute of horsepower. We will use the attribute accessor that dot horsepower 500. I will add HP meaning horsepower. Alright, now for the whiz, I will add another placeholder access self access our whiz. Now our whiz, it is a list. I don't need all for whiz. I just need one. If I was to take my list, then access the size. This is what it will give me list. Object has no attribute size. So we need to access one of the elements of our list of wheels. Let us just say the first wheel and index 0. Then give me the size 18 and that is going to be inches. Alright. Then let us create a second car object. Before we finish, we have car 1, car 2 equals car. We need a make model, horsepower for the engine and wheel size for the wheels. I will pick a Chevrolet Corvette and I am just going to make up some numbers. The horsepower is 670 and the wheel size is 19. Let us display car 2. Car 2 called the display car method. We have a Chevy Corvette with horsepower of 670. The wheel size is 19-inch. So our car class, it owns some objects. It owns an engine and it owns 4 wheels. That is why composition is different from aggregation. If I were to delete these 2 cars, this engine and 4 wheels would stop existing. Whereas in our library example in the last video, if I was to delete the library object, the books will still exist. Alright everybody, so that is composition. It is here a composed object. Our car directly owns its components. Our car owns an engine and it owns phones for wheels. We are creating them within the class. And well everybody, that is composition in Python. Hi everybody, so in today's video I got to talk about nested classes in Python. A nested class is a class defined inside of another class. This has a few benefits. We can logically group classes that are closely related. We can encapsulate private details that are not relevant outside of the outer class, and also it helps keep our namespace clean. It reduces the possibility of naming conflicts. So for example, let us say we have 2 classes, both named employee. Within this class, I am just going to print something. This is the first class. Then let us copy our employee class, paste it again. This is the second class. We have a naming conflict. We have 2 classes with the same name. If I were to run this program, we will execute both. This is the first class. This is the second class. It is fairly noticeable that we have two classes with the same name. But with Python, we do a lot of importing and exporting of large files. We may not realize there is a name conflict. One concept that will help as avoid naming conflicts is the use of nested classes. Let us say we have employees for a company and another set of employees for a non-profit organization. I could write something like this. We will create a class of company. Within this class of company, we will have an in class of employee. With our second employee class, we will create an outer class of non-profit. This is perfectly fine. We can have two classes with the same name as long as they are within different scopes. These two employees classes might have different attributes depending on who they work for. If they work for a company, they might have one set of attributes. If they work for a non-profit, they might have a different set of attributes. So by using nested classes, this helps keeps the namespace clean. We can reuse this employee class because they have different scopes. Now, what are we going to do in this example? What we will do in this example is create some employee objects that belong to a company object as a placeholder. For now, I will write pass within the employee class with our class of company. Let us define a constructor. Do pay attention to the indentation. We are within the company class but not the employee class. This constructor is for the company object we are going to create. If we construct a company object, we need a company name such as the Krusty Krab. I will assign self.company name is equal to the company name that we receive. We are also going to declare an attribute of employees. This attribute will be an empty list. We will append employee objects to our list of employees. Then we will create a method to add employee. We will need a name, meaning name of the employee, and a position. What is their job? For now, I will write pass. We will get back to this later, and I will define a method of list employees, and again I will write pass. Okay, let us be sure that our company name works. I am going to create a company object. Company is equal to company, but I have to pass in a company name. I will pick the Krusty Krab. Then, just to be sure that this works, I will display our company's company name attribute that would give me the Krusty Krab. So we know that works within our employee class. Let us define a constructor. Define in it. We need a name and a position. Self.name is equal to name self dot pause equals position. Let us create one more method. Define get details. We will return the details of an employee. All we are going to do is return an f string, add two placeholders, and we will return self.name and self.pause. Alright, now within our add employee method, we will construct a new employee object equals. Now if we are going to access this inner class of employee, we are going to prefix self meaning this company object that we are currently working with. We need the class of employee. Then we will call the constructor, but we have to pass in a name and a position. When we receive a name and a position, we will pass that to the employee constructor. Once we have our new employee object, we are going to take our list of employees, self.employees. Use the append method of list. Then add our object of new employee to this empty list. Let us create a few employee objects. We will take our company. Use the add employee method that we have created. We need a name and a position. I will pick Egwin for Egwin Krabs. His position is that he is manager. Let us create two more. Take our company object. Use the add employee method that we have defined. I will pass in the name of this employee as SpongeBob. His position is that he is a cook. Then we have Squidward. Company.add employee method. First name Squidward. His position is that he is a cashier. So this would run with no problem. So now I would like to list all of the employees at this company. We will need to rely on this get detailed method. So when we list our employees, we will return a list comprehension for every employee in self.employees. This is an attribute. It is a list of employees objects. It is iterable. Take each employee that we are iterating through call the get detailed method and return it. Now if I was to take my company, then call the list employees method. Oops, I forgot to print it. We will print each employee's name and their position. However, I think this would look better if we were to use a for loop for every employee in take our company call the list employees method. During each iteration we will print each employee. We have Adrian, that is Mr. Krabs, the manager, SpongeBob, the cook, the Squidward, the cashier. To demonstrate the reusability of classes, let us create a second company object that has its own employees. Let us rename company as company 1. Then we will create company 2. Company 2 equals called the company constructor. My second company will be the chum bucket. We will take company 2, then add 2 employees. Company 2, add employees, we will pick Sheldon. Sheldon is the manager company 2. Add employee Karen will be the assistant for every employee in company 2. List the employees during each iteration. Print the current employee. We have Sheldon, that is Plankton's first name. He is the manager. The Karen is his assistant. Alright, everybody. So, those are nested classes. It is a class defined inside of another class. You have an inner class and outer class. Few of the benefits is that we can logically group classes that are closely related, such as having employee objects within a company object. We can encapsulate private details that are not relevant outside of the other class. We may have no need to create employee objects outside of this class, and by using nested classes it helps keep the namespace clean. It reduces the possibility of naming conflicts with another type of organization. We could create another inner employee class and well everybody. Those are nested classes in Python. Hi everybody. Today I am going to talk about static methods in Python. A static method is a method that belongs to a class rather than any object from that class, any instance methods. We are already familiar with them. They are methods that belong to individual objects created from that class. They are based for operations on instances of that class any objects, whereas static methods they are based for utility functions within a class that do not need access to class data. I will demonstrate the differences between an instance method and a static method. We will begin with creating a class of employee. We will need a constructor. Let us define that to create an employee object. We will need a name and a job position. We will assign self.name is equal to name, self.position is equal to position. We will create an instance method of getInfo. We will return employee info. We will return an f string where we will display self.name is equal to self.pos. GetInfo is an instance method. Each object that we create from this class will have their own getInfo method to return the information on this object, the object's name and the object's position. Now we will create a static method. To create a static method, we need a decorator of static method. Static methods are best for general utility functions within a class. We will define a method to check to see if a job position is valid, which we will name is valid position. So static methods, they don't have self as the first argument. We are not working with any objects created from this class to check to see if a position is valid. We will pass in a job position which I will name as position. I will create a list of valid positions. Let us assume that our company is the Krusty Krab. What are some valid positions? A manager is a valid position, a cashier, a cook, then let us say a janitor. Then we will return. We will use a membership operator. Check if position that we receive is in our list of valid positions. What we have done is that we have created a static method. We don't need to rely on any objects to use this method. For example, to use a static method, we will use the name of the class rather than any object that we create from this class, such as this. We don't need to do that. We type the class name followed by the static method is valid position. Then I did set this up to accept one argument. Let us check to see if a cook is a valid position. Then I do need to print this. What is the output? A cook is a valid position. What about a rocket scientist? That would probably be says job. That is false. A rocket scientist is not a valid position at the K Krusty Krab. This is a static method. It belongs to the class, not any object created from that class. Now let us create a few employee objects. Let us say employee 1 equals a new employee. We have to pass in a name and a job agent will be the first name, that is Mr. Krabs. He will be a manager. Employee 2 is equal to employee. Squidward will be a cashier. Employee 3 is equal to employee. Employee 3 will be a SpongeBob. SpongeBob will be a cook. To call an instance method, we have to access one of the instances of the class in order to use it. If I want to check the info on employee 1, I will access that object. That instance use the getInfo method. Then I need to print it. Take employee 1, get the info. Adrian is the manager. Let us do this with employee 2 and employee 3. Adrian, Mr. Krabs is the manager. Squidward is the cashier. SpongeBob is the cook. For an instance method, you access an object. Then call the instance method with the static method. You only need to access that class. You don't even need to create any objects from that class. It is a general utility method. Alright everybody, those are static methods. They are a method that belongs to a class rather than any objects created from that class. They are usually used for general utility functions that do not need access to class data. And well, everybody, those are static methods in Python. Hi, so today I got to talk about class method in Python. A class method allow operations related to the class itself. They take CLS as the first parameter, whereas instance methods will take self. Self refers to any object created from that class. CLS meaning class refers to the class, not any objects. Here is an example. We will create a class of student. We will need a constructor to construct more student objects. All students will have a name and a GP. Self.name is equal to name. Self.gpa is equal to GPA. We will also create a class variable for this demonstration of count. We will count how many students we create whenever we construct a student object. We will access the class of student. Take our count variable, increment it by 1. Whenever we create a student object, increase count by 1. I will create an instance method of getInfo. Instance method have self as the first parameter. We are referring to the object we are currently working with, and I will return an F string where we will display the student's name and their GPA. Self.name, self.gpa. I will add a comment that this is an instance method. Now to create a class method to work with class data, we will declare a class method with a class method decorator class method. What we are going to do is define a method to get the count, the class variable of count. This method will be called getCount rather than self as the first parameter. We will be working with a class CLS meaning class. I will return an F string. Total number of students add a placeholder CLS count. Let us test this to call a class method to take the name of the class followed by the class method getCount, and then we do need to print this. What is the count of my current students? Total number of students is 0. Let us create a few student objects. We will create student 1 is equal to called the student constructor. We have to pass in a name and a GPA. Let us say that the name is SpongeBob. SpongeBob has a GPA of 3.2. We will create two more students. Student 2, student 3. Student 2 will be Patrick. Patrick has a 2.0. Then Sandy. Sandy is smart. In fact, she is a genius. She has a perfect 4.0. Now let us count the number of students. Total number of students is 3. Then we call this class method. We can access or modify class data. This class variable of count rather than using self. We use CLS for the class. Let us create one more class method. This time I will calculate the total GPA of all students. We will need a class variable to hold that data. Let us say total GPA equals Z. Whenever we construct a student object, we will access our class of student, get the total GPA, then add plus equals this student's GPA that we have just created. Basically speaking, the total GPA, this variable is going to accumulate all of the GPA of every student and store it as a sum to find the average. We are going to divide it by the count, the number of students. We will do that within a class method. To create a class method again, we need to use the class method decorator. We will define a method of getAverageGPA. The first parameter is CLS for class. I will check if CLS count, the count variable of my class is equal to 0. That means if we have no students, if that is the case, if there is no students, we are going to return 0, because otherwise we are going to divide by 0 and we will get an error. Yes, we are going to return an F string. Follow this formula. We are going to take the total GPA of my class dot total GPA divided by class dot count, the number students we have. That is how to calculate the average GPA. After getting the count of the number of students to access the class method, we take the name of the class student, call the class method, get average GPA, then I will print it. Total number of students is 3. The average GPA is 3.06. Repeating after calculating the average, I am going to add a format specifier of 2f just around to 2 decimal places, and I will add average GPA colon space, then we will calculate the average. Alright everybody, those are class methods. Instance methods are based for operations on instances of the class any objects. Static methods are based for general utility functions. We do not need access to class data. Class methods are best used when we are working with class level data or we require access to the class itself, such as when we are working with class variables. Rather than using self as the first parameter, we are going to use CLS, meaning class, and well everybody, those are class methods in Python. Hi, today I am going to explain magic methods in Python. Magic methods are also known as dunder methods, meaning double underscore. You typically find these within classes. We are already familiar with one of them, our dunder init method. We have double underscore on the left and double underscores on the right, but there are others. I will cover a few of the more beginners friendly ones. So what these methods do is that they are automatically called by using some of the Python's built-in operations, such as printing an object, seeing if two objects are equal, greater than, or less than. When we use many of Python's built-in operations with objects, we can define and customize the behavior of those objects. So in this demonstration, I am going to create a class of book. We will construct some book objects. We will define a magic method, a dunder method of init. To initialize these objects for a book, we need a title, an author, and a number of pages. We will say num pages self.title is equal to title, self.author is equal to author, self.number of pages is equal to number of pages. When we call the class of book, we are automatically calling dunder init. So let us create a book object. Book 1 is equal to book. We need a title, an author, and number of pages. So since we are dealing with this topic of magic methods, I will pick some fantasy related books. For my first book, I will pick The Hobbit, that is the title. The author is J.R.R. Tolkien. The number of pages is 310. So for my next book, book 2, I will pick Harry Potter and the Philosopher's Stone. The author is J.K. Rowling. The number of pages is 223. Then we have book 3. For my third book, I will pick The Lion, the Witch, and the Wardrobe. The author is C.S. Lewis. The number of pages is 172. Okay, here are my 3 book objects. When we call the class of book and pass an argument, we will call the dunder init method. It is a magic method. It is automatically called behind the scenes. Within this magic method, we can define and customize the behavior of objects. And in this example, we are just assigning the attributes of title, author, and number of pages. That is one built-in operation of Python. That would happen if I was to print book 1 directly to the console. Here is what happens. Well, we are given a memory address. Here is book 2 and book 3. Well, we can customize this behavior. We will use the dunder string method double underscore st. str meaning string double underscore. Again, we have one parameter of self. Instead of returning a memory address, we can customize this behavior. Let us instead return an f string. I will add two placeholders. We will display self.title, the title of the book by self.author, and I will place the title within single quotes. Now let us print book 1. We have The Hobbit by J.R.R. Tolkien. Let us print book 2. Harry Potter and the Philosopher's Stone by J.K. Rowling, and book 3. The Lion, the Witch and the Wardrobe by C.S. Lewis. So that is thunder string. We can return a string represent A of the object when we print it directly to the console. Here is another dunder method. We can check to see if two objects are equal. I will print this book 1 equal to book 2. That gives me false if they were to have the same title, the same author, and the same number of pages. Then Python would say they are not equal still. So let us customize this behavior. We will define a method of dunder equals, which is just eq for parameters. We have saved the first book. We are examining in this case book 1 and other means the other book. We are examining two objects for equality. To do that, we will see if the title of the two books and the author is the same. We will disregard the number of pages. You can have two different versions of same book. They might have different font sizes of the dimensions of the physical pages might be different. So we will return a boolean value. We will examine if self, that is the first book, is the title attribute equal to our other book's title, and is the author of the first book self.author is equal to our other book's author. If I were to run this, we get false. Book 1 does not equal to book 2. But if they have the same title, I am going to replace these and same author, then they would be equal. And we will disregard the number of pages. Let us say that with this version of The Hobbit, they are using a smaller font size, so there is less pages. We are using under equals to compare. If two objects are equal, what if I was to print book 2 is less than book 3? Like, what does that even mean? And I am just going to get rid of these two lines. Type error less than is not supported between instances of book and book. So we cannot use less than on two objects, but we can customize that behavior by using dunder less than, which is just lt. We are examining one book and other book, self and other. Let us compare the number of pages. We will compare if the pages of book 2 is less than book 3. We will return a boolean value. Is self dot number of pages less than other dot number of pages. So now this should not give us an error. Book 2 does not have less pages than book 3. Another would be greater. Then I will just copy what we have under GT for greater than for our first book of self. Is it greater than the number of pages of the other book? Well, that is true. The number of pages of book 2 is greater than book 3. Let us use dunder add to add the pages of two books together. What would happen if I were to add two books together? Book 2 plus book 3. Well, but get a type error. Unsupported operand for book and book. Well, to customize the behavior of addition, we will define dunder. Add we have self and other for the other object. Let us add the pages together of two books. Maybe we need a summer reading list and we would like to see what the total number of pages is. I will return self dot number of pages attribute plus our other books number of pages that would give me 395, that is 223 plus 172. Heck, I will even put this within an f string cu. Why not? Then I will add the word pages, 395 pages within an object. We can search for a keyword within one of the attributes. So let us find the word, the lion within book 3. To do that, I would write a statement like this lion in book 3 type error argument of the type book is not iterable. We will define dunder contains besides self. We will pass in a keyword that we are searching for. I will return. Then we will use the in membership operator is for keyword in self dot title. I am looking for the word lion, that is going to return true if lion is in the title of this book or is our keyword in self.author. Maybe we are searching for an author. Let us try that. Again, that returns true. Lion is in book 3. However, lion is not within book 1. That is false. Is it rolling in book 2? That is the author. That is true. Is rolling in book 3? That is false. That thunder contains. We are searching for a keyword in an object. Now we would search for a key given an object for book 1. We will use the index operator and look up an attribute. Let us get the title of book 1. The default behavior is that we get a type error. Book object is not subscriptable. So to customize this behavior, we will use dunder. Get items besides self. We have one parameter of key. We are accessing book attributes by indexing with this object. Return the value at this key. What is that attribute? We will check. If our key that we receive is equal to title, which is in this case, we will return self.title. What is the title of the book? That would give me The Hobbit. Here is book 2 and book 3. What if the key is author? None. We did not set that up yet. If the key is equal to author, then return self.author. The author of book 3 is C.S. Lewis. 2 is J.K. Rowling. Book 1 is J.R.R. Tolkien. What about the number of pages? Num pages? Well, we are not set up for that yet. I am going to turn this into an else. If statement else, if key is equal to num pages, then we will return self.num pages. The number of pages in book 1 is 310. Book 2 is 223. Book 3 is 172. What if there is no key? Otherwise, if there is no matching key, I will add an else statement. Let us return an f string key placeholder rk that we pass in as an argument was not found. What do books not have? Well, they don't have audio. I guess unless it is an audiobook. Is there a book of audio in book 3? There is not. Key audio was not found, and I will place that within single quotes much better. Alright, everybody. So, those are magic methods, also known as thunder methods, meaning double underscore. They are automatic called by many of Python's built in operations. They allow developers to define or customize the behavior of objects when we use those built in operations. And well, everybody, those are magic methods in Python. Hi everybody. So in today's video I got to talk about the property decorator. In Python, the property decorator allows us to define a method as a property. We can access it like it is an attribute. One of the benefits is that when reading, writing, or deleting attributes, we can add additional logic. The property decorator gives us a getter method to read, a setter method to write, and a deleter method to delete. When working with attributes in this example, we will create a class of rectangle. We need a constructor. Let us define that. When constructing a rectangle object, we will need a width and a height. We will assign the attribute of width equal to the width that we received. When constructing this object, self.height equals height. Let us construct a rectangle object. Rectangle equals rectangle. We need to pass in width and a height. Then I will print my rectangles width rectangle dot width and height rectangle dot height. With my rectangle, the width is 3, the height is 4. Using the property decorator, when reading these attributes of width or height, I can write some additional logic. Let us say that when accessing the width or the height, I would like to display one digit after the decimal. Then add centimeters. Here is one way in which I can do that. For each of these attributes, I am going to create a method. We will define a method of width, no parameter besides self. For now, I will write pass and define the height. Proceeding each of these methods, I will use the property decorator. So at property, now when accessing the width or the height will be returned with whatever is within these methods of width and height. But there is one change. We are going to make to these attributes. We will set these attributes to be private prefix. Each of these attributes with an underscore. This tells you and other developers that these attributes they are meant to be protected. They are internal. We should not access the width or the height directly outside of this class. Technically, we could. I will access the internal version of width and height. We get 3 and 4. But we do have a warning access to a protected member width of a class that applies to height as well. Our width and our height are only meant to be used inside of this class. If we need to get the width and height, we will do so through these getter methods provided by the property decorator. So when accessing the width, let us return an f string. I will pass self dot private width. Add a format specifier to display one digit after the decimal 1, f followed by sense mem. We will do this with the height as well. We will return self.private height. So now when we access the width or the height, we will do so using this getter method. If I access this private width and height attributes instead, again they will be 3 and 4. It is kind of like the raw these attributes are meant to be used internally inside of the class. So that is the point of a getter method. We can add additional logic when reading one of these attributes. When we try to get them, we can also add setter methods if we would like to set or write those attributes. Here is how. Let us take our width. We will create a decorator of at width.setter. When attempting to set the width, we will do so using this method. We will define our method name of width. We will have one parameter, a new width. We don't want the parameter name to be the same as the method name. That is why we are naming it something different when setting the width. Let us check to see if the new width is greater than 0. If so, we will take self.private width equals our new width. Else, let us print something. Let us print width must be greater than 0. And let us do this with the height. Height.setter define height. Pass in a new height. If our new height is greater than 0, assign self.private height equals the new height. Else, print height must be greater than 0. Before printing the width and the height, let us take our rectangle width, set it to be 0, then see what happens. Well, we get that message width must be greater than 0. If I were to set width to be 5, well, that does work. Our width is now 5. Let us change the height. Rectangle.height. I will set this to be -1. Height must be greater than 0 and the height has not changed. What about 6? 6 does work when using the setter methods. We can add additional logic when writing or changing one of these attributes. These are setter methods. Now, if we need to delete an attribute, here is how. There is a delete keyword. We will delete our rectangle's width and delete our rectangle's height. In this series, we really won't be using the delete keyword, but you should still know that it exists. So we will create a deleter method to take one of the attributes. In this example, we will create a deleter method. The method name will be width and the name of the attribute. There will be no parameters besides self. We will delete self.private width. Then let us print something just to confirm that this was deleted. Width has been deleted. Same thing applies to height. Take the attribute of height. Define height. Delete private height. Height has been deleted. When deleting our width or our height, we get that confirmation message. Width has been deleted and height has been deleted. Alright, everybody. So that is the property decorator. We can define a method as a property, meaning it can be accessed as if it was an attribute. One of the benefits is that we can add additional logic when we read, write, or delete attributes. The property decorator gives us a getter, setter, and deleter method. Getter methods to read, setter methods to write, and deleter methods to delete. And well, everybody, that is the property decorator in Python. Thank you very much.